Okay, in this first problem, we're going to evaluate, so that means we're going to find the value of this whole thing. They already give us the value of x, so all we have to do is take that 15 and substitute it in for x. So 5 plus 15 divided by 5 minus 3 squared. Okay, we're going to follow the order of operations. No exponents, so we move, no parentheses, so we move on to exponents. I see 3 squared, so we'll rewrite everything else. 5 plus 15 divided by 5 minus, and then 3 squared is 9. We then move on to multiplication or division. I see division. 5 plus 3 minus 9. Move on to addition and subtraction. 5 plus 3 is 8. 8 minus 9 is negative 1. Okay, problem number 2. We see in the numerator we have x times y plus 8. Denominator x plus 6 minus y. We're going to take the values for x and y and substitute them in for x and y. So on the top, the numerator, we have x times y, so the value of x is 5 times the value of y is 4 plus 8. And the denominator, take the value of x, 5, plus 6, minus the value of y. Okay, so we will evaluate just the top part first. So 5 times 4 is 20. 20 plus 8 is 28. So our numerator will be 28. And our denominator, we're going to evaluate that. So 5 plus 6 is 11. So 11 minus 4 will give us 7. Now that we have a fraction set up with just a number on top and the bottom, we will solve that. So 28 divided by 7 is 4. Okay, problem number 3, we're going to do the same thing. We will take the values that they give us for x and y, and we will substitute them in for the x and y we see in the problem. So it's 4 times the value of x squared plus 4 times the value of y plus 8. Okay, we'll follow the order of operations. I do have parentheses, but it's just a single number inside of each. So we move on to exponents. And I see 3 squared here, so we will work that first. So it's 4 times 3 squared, which is 9, plus 4 times 2, plus 8. Okay, 4 times 9 is going to give us 36, plus 4 times 2 is 8, plus 8 more. 36 plus 8 is 44, plus 8 more will give us 52. Okay, example number 4, we only have one variable, so we will substitute 12 in for x. And we're going to rewrite the problem as 6 minus 12 squared plus 5. Okay, order of operations, 6 minus 12 gives me negative 6. And then we still have the exponent of 2 outside. So let's fix that. 2 plus 5. So negative 6 squared will give me 36 because it's negative 6 times negative 6. And we will add 5, and that gives us 41. Okay, in problem number 5, we see it's a negative times x times y. So we have to be careful when we have this negative outside of a term. This means negative 1 times x, or times the value of x. So really we have negative 1 times negative 5 times negative 9. So we're going to write that out. So the symbol stays there, negative value of x times the value of y. And we will now evaluate that. So negative here times negative 5 is going to give me positive 5. times negative 9, and that will give me negative 45. Okay, in this last problem, we see that we have two variables. We have x and y. So x is negative 2, so we will substitute that in for x, and y is 8. When we're substituting in for x and we have this exponent here, we need to make sure that this value for x goes in parentheses. So it's negative 2 squared, because we want to take the value of x and square it, so we take that whole piece and square it, right? Plus 3 times the value of y minus 7. So order of operations, we see parentheses, but no operations inside, they're just single numbers. So we move on to the exponents. So it's negative 2 times itself, that's what squared means, so negative 2 times negative 2 gives me positive 4, plus 3 times 8 minus 7. I move on to multiplication and division. I see multiplication, so it's 4 plus 3 times 8, which gives us 24, minus 7. Addition or subtraction from left to right. 4 plus 24 is 28. 28 minus 7 is 21. Okay, for 7 through 12, we're going to translate these English phrases into algebraic expressions. So in order to properly do this, we need to look for keywords that tell us what to do. In this first problem, I see the phrase sum of. So we know when we see sum of or difference of that we're going to put something in parentheses. I'm going to take the x and 4, and it says to sum them, so I will add them. So x plus 4. In number 8, we have quotient of 9 and g. Quotient means the answer to a division problem, so I'm going to show the division of 9 and g. So 9 divided by g. On number 9, it's 8 less than v. Less than tells us to subtract, and then the word than is called a turnaround word. So instead of writing it 8 minus v, we're going to turn these two things around, right? So the v is going to go in the front, and then it's going to be 8 less than that. So it's going to be v minus 8, or 8 less than the starting value of v. Number 10, 6 increased by twice x. Increased by means to add. I don't see any turnaround words, so it's 6 increased by twice x. Twice means times 2. 2x. Okay, number 11, x decreased by 12, all divided by 3. So we see a comma there, so x decreased by 12 is going to go first. X decreased by 12, and then it says all divided by 3. Another way to write that would have been x decreased by 12 in parentheses, and then all of that divided by 3. So the parenthesis says, hey, do this first, and then divide it by 3. Okay, number 12, 5 times the difference of y and 2. I see two different operations here. I see times, and I see difference of. Difference of tells me that I need a set of parentheses for the terms that come after that. So I have y and 2. Difference of means to subtract. So it's y minus 2. And then 5 times that difference. So we have 5 times the difference of y and 2. Okay, number 13. The width of a rectangle is 3 less than twice the length, L. Write an expression below that represents the width of the rectangle. So, first thing I notice is it's asking me to write an expression. So there will be no equal sign in here. We just want to write a regular expression. In algebra, is means equals. So we're saying the width of the rectangle equals 3 less than twice the length. All we want is to write an expression using this portion here. We don't want the equal sign or the W in it, right? We don't want the width. We just want to know an expression that represents the width. So I will take 3 less than twice the length. Less than tells me to subtract. Than tells me to turn it around. So it's going to be 3 less than twice the length. Okay, at a local ice cream parlor, the cost for a plain sundae S is $3, and each topping is an additional $1.25. Write an expression that could be used to determine the total cost of a sundae with additional toppings. So first thing I notice is it says write an expression, so there is no equal sign, but we want to know, or we want to have an expression that represents the total cost. So in order to find the total cost, we need to take the price of the ice cream and the price of the toppings and write an expression using those two pieces. So the price of the sundae itself, just the ice cream, is $3, and each additional topping is $1.25. So to write that, I would say it's $3 just for the ice cream plus $1.25 per topping. So I'm going to use the variable t to represent toppings. Okay, number 15 says write an expression for Scott's age if he is 5 years older than twice Jenny's age. Use the variable j for Jenny's age. Once again, looking at the directions, says write an expression, so there is no equal sign. So Scott's age equals this phrase, 5 years older than twice Jenny's age. So 5 years older than, that's the turnaround word than. So 5 years older than, and then it's twice Jenny's age. So I'd represent that with 2j, twice j, or 2 times j. Okay, in the last set of problems, we are going to simplify. And all simplify means to do is just to combine things that are the same or distribute if possible. Of course, we would want to distribute first and then combine like terms. So in this first problem, number 16, I see that I have no distribution, but I have 2 x's, 3 y's, negative 8 x's, and 3 more y's. So I want to combine the things that I can. So I'm going to take all of the x's and combine them. So I have 2 of them here and minus 8 of them here. Together, that's going to give me negative 6x. And then I have 3 y's here and 3 more here. So it's plus 6y. In problem number 17, we look to distribute first. I don't see any distribution, so we will combine like terms. I have 3x's here, plus a negative 6x there. Together is negative 3x. And I have a constant term all by itself, so nothing to combine there. So negative 3x plus 12. Okay, problem number 18. I look to distribute first, and I do see distribution this time. So we're going to take this 2 and distribute it to each of the terms. So 2 times 7x gives me 14x. 2 times a positive 2 gives me positive 4. I then would try to combine terms, but I cannot because this one has an x and this one does not. So it is simplified as we see it. Okay, so we want to simplify number 19 as well. We will look to distribute first. So I have a negative 8 times x. It's negative 8x. And then a negative 8 times negative 2, which gives me a positive 16. I then look to combine like terms, which I cannot because we have x's here and just regular constants or just regular numbers there with no variable. So it is simplified as is. Okay, number 20, we want to distribute if possible, and we don't see any numbers just sticking out showing us to do that, but we do see this negative sign in front of this set of parentheses. So I do want to distribute this negative to each of the terms inside of the parentheses. And what this really means is I have a negative 1 times each of these pieces. So we're going to take the negative 1 and distribute it to each. So it's negative 9. And And then a negative times a negative 5x gives me positive 5x. And then we're done with the parentheses, so I write the terms after that down. So plus 4x plus 12. Okay. Then I will combine like terms. I have positive 5x plus a positive 4x gives me 9x. Then I combine my constants. So I have negative 9 plus positive 12 gives me positive 3. In problem number 21, same thing. We want it to distribute if possible. I have a positive 4 times each of the terms inside of the parentheses. So 4 times positive 1 is positive 4. And positive 4 times this negative x gives me negative 4x. I will then combine the like terms. Gives me 3x. And then the constant by itself is plus 4. And there's nothing else to combine. In problem number 22, I see a half outside of a set of parentheses. So that means I need to distribute this half to each term in here. 6x, and then we have a half times 8x. So that gives me, so it's basically saying half of 8x would be 4x. And then half of this negative 10 is going to give me negative 5. I'll then combine like terms. I have positive 6x plus 4x gives me 10x. And then I have this constant by itself. Okay, number 23, we will distribute this negative 6 to each of the terms inside of the parentheses. So we have that first term 6, we just brought it down. And we take the negative 6 times this positive 4, negative 24. Negative 6 times positive x is negative 6x. And then plus 13x's. We will combine like terms. I have negative 6x's plus 13x. Leaves me with 7x when I combine them. And then I take the constants. So I have positive 6 added to a negative 24. Leaves me with negative 18. Okay, number 24, we look for distribution first, and I see that I actually have 2 times that I need to distribute. So I need to distribute this 2 to each term inside of that first set of parentheses, and I need to take this positive 4 and distribute it to each of the terms inside of that set of parentheses. So we'll always start with the first one, left to right. I'm going to take this 2 and distribute it to the 3x. That's 6x. And then 2 times positive 5 is 10. And we're going to take this positive 4 and distribute it. So it gives me positive 4x, or plus 4x. And then positive 4 times negative 3 will give me negative 12, or minus 12. I will then combine like terms. 6x plus 4x gives me 10x. And then 10 plus a negative 12 gives me negative 2. Okay, number 25, we're going to take the principles of simplifying and use it to find the perimeter of a shape. So it says if the width of a rectangle is 3y plus 8 and the length is 2x plus 5, what is the perimeter? Okay, so we know that perimeter means to add up all the sides of a shape to find the distance around it. Anytime they give you a problem without a picture, if it's something you can draw it. So it says rectangle, so I want to draw a rectangle first, and then I want to label the sides based on what they gave me. So it tells me that the width of the rectangle is 3y plus 8. So we'll put 3y plus 8. Okay. Then the length is 2x plus 5. 2x plus 5. If I want to know what the perimeter is, I need all of the sides to be added up. So that means I need to go ahead and write the other sides down as well. So 3y plus 8 and 2x plus 5. So it's exactly the same as it was before, except they're just not all lined up. So I'm going to take all of the x's that I have, and I'm going to add all of them up. Then I'll take the y's, and then I'll take the constants. Okay. So I have 2x's here and 2x's here. That gives me 4x. Then I'll take my y's. So I have 3y plus another 3y. So that's plus 6y. And then I'll take the constants. So there's a plus 8, plus 5, plus 8 more, plus 5. Okay? 5 plus 5 gives me 10. That 10 plus 8 is 18. Plus 8 more gives me 26.